It began like a whisper through the dark, a faint point of light, no brighter than a candle across an ocean of night. On an October evening in 2017, telescopes scanning the sky caught a moving dot that didn't belong. It wasn't circling the sun like our familiar comets or asteroids. It was racing through, cutting across the solar system on a path that bent once, then never curved back. Astronomers would later call it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was the first recorded object known to come from another star. At first, the data looked ordinary: position, brightness, motion. But something about the numbers hummed with quiet defiance. Its speed was too high, its orbit too open. It was on a hyperbolic trajectory, which meant gravity would never bring it back. This was no child of our sun. It had crossed the invisible border between the stars, drifting for millions, perhaps billions, of years before wandering close enough to be seen. It wasn't glowing. It wasn't trailing a tail like comets do. It simply moved, a dark traveler in the light, sliding through the cradle of silence that stretches between planets. The night sky, so familiar to us, suddenly felt alive again, as though an ancient visitor had stepped into our quiet neighborhood, uninvited, unannounced, and unforgettable. For those listening to this story in the calm of night, as you drift toward sleep, that's exactly why these cosmic tales exist. If you're listening as your room darkens and the stars shimmer outside your window, take a quiet moment to be part of something vast. Subscribe and share where you are and what time it is. New York at midnight, London before dawn, Sydney in the sunlight. I read them all, like a constellation of listeners scattered across Earth, each one shining back a small reflection of the same endless sky. Back then, Oumuamua's discovery felt like the soft turning of a page in a story we didn't know we were writing. The telescope that found it, Pan-STARRS in Hawaii, recorded it by chance, a faint streak against the static field of stars. Within hours, astronomers across the world pivoted their instruments, trying to hold on to the fleeting visitor before it vanished into the void. Its brightness flickered irregularly, as if it were tumbling end over end. That suggested a strange shape, long and thin, maybe like a cigar, or perhaps flat and wide like a shard. Nobody could agree, and no telescope could get close enough to see clearly. In the days that followed, observatories from Chile to Arizona traced its arc. The numbers spoke in gentle certainties: speed 196,000 miles per hour, trajectory hyperbolic, origin outside the solar system. But beyond the math, there was something deeper, something poetic. The first interstellar object ever observed by humans had arrived quietly, like a note slipped under the door of our cosmic awareness. It didn't shout, it simply was. Imagine standing outside on a cool night, the air still, the horizon faint, with twilight. Above you, a soft brush of starlight spans the sky. Somewhere up there, invisible to the naked eye, the traveler once passed, silent, ancient, solitary. For all we know, it may have crossed the debris of broken worlds. The faint shimmer of dying suns, the soft glow of nebulae where new stars are born. By the time it reached us, it carried no heat, no signal, just motion, pure and unending. Scientists measured its acceleration as it approached the sun and found something curious. It sped up slightly, as if pushed by a gentle pressure. But no gas or dust cloud followed it. Comets do that when they outgas, but Oumuamua remained clean and dry. Some said it was made of hydrogen ice. Others imagined metallic rock polished by cosmic dust. A few wondered if it was something else entirely, a fragment, a sail, a relic from a civilization we would never meet. The scientific papers were careful, the speculations less so. Still, what mattered most wasn't what it was, but what it meant. For centuries, humanity had looked outward, asking if anything out there had ever reached in. And now something finally had, even if it said nothing, even if it was only a wandering rock. In the quiet of midnight observatories, scientists whispered the same question countless poets had asked beneath those same stars. What else is out there? As Oumuamua curved around the sun, it reflected just enough light to reveal subtle color, a reddish tint, like oxidized metal or baked clay. The solar wind brushed against it, faintly, a stream of charged particles flowing from our star. That wind could not slow it. It continued outward, slipping past Mars, past Jupiter's distant glow, past the frozen edge where sunlight fades into memory. Each night, telescopes watched it dim, the way one might watch a ship disappearing over the horizon. Soon, it became too faint to follow. The data ended. The traveler continued, unseen, unmeasured, but not forgotten. In its silence, Oumuamua reminded us that the universe doesn't need to be loud to speak. Every orbit, every reflection, every slow drift of dust tells a story written in gravity and light. Sometimes, it sends us visitors to remind us of that language, brief flashes of motion across the static night. As you lie beneath your own piece of that same sky, think of the paths that cross without meeting, planets circling, comets falling, light scattering across the atmosphere. Somewhere far beyond the reach of telescopes, Oumuamua still travels, tumbling gently through the cold. Maybe it will pass another star, become a myth in another world's sky, or perhaps fade forever into the black between galaxies. But even in its fading, it left something behind, a question we cannot stop asking. If one stranger has already passed us by, could there be another, hidden still in the dark? And in that silence, deeper than sound, softer than sleep, the universe seems almost to answer. It began as a pixel barely more than a whisper of light sliding across telescope images in October 2017. Astronomers at Haleakal Observatory first thought it was an asteroid, another ordinary rock looping around the sun. But within days, the data bent in an unexpected way. Its orbit wasn't an ellipse like every familiar comet or planet. It was a hyperbola, an open curve that never closes. Oumuamua wasn't returning. It was just passing through. The name came later, drawn from the Hawaiian word meaning a messenger from afar arriving first. It fit perfectly. Oumuamua was unlike anything we had seen. Long and narrow, perhaps 10 times as long as it was wide, spinning rapidly, tumbling as it moved. If you could have watched it up close, it would have resembled a thin, elongated shard of metal or dark rock. Glinting faintly in the sunlight, its surface cold and quiet. Astronomers tracked its path as it swept past the sun, dipping inside the orbit of Mercury, then slingshotting outward faster than any asteroid known. When it came near perihelion, the point closest to the sun, something strange happened. Its trajectory shifted slightly, a faint acceleration, as if pushed by an invisible breeze. But there was no tail of gas, no plume of vapor to explain it. Ordinary comets release jets when ice sublimates into vapor, creating a visible tail and a measurable push. Oumuamua didn't. The push was real, but the cause was hidden. In the soft glow of distant starlight, telescopes watched. Spectrographs, which divide light into its many colors, tried to decode the mystery. The results were frustratingly unclear. Its surface reflected sunlight like something reddish and metallic, similar to long-weathered iron or carbon-rich rock. Yet there were no clear absorption lines, no fingerprint of familiar minerals. Some scientists suggested it was covered in organic Tholen's complex molecules formed under cosmic radiation. Others thought it might be a crust of dry dust hiding ice within. But none of those guesses fully explained its strange push or its cigar-like shape. It spun once every 8 hours, wobbling like a baton thrown into slow motion. That motion caused its brightness to rise and fall as it rotated, confusing early observers, who thought it might be a cluster of smaller fragments instead of a single body. Each rotation revealed new clues and erased others. Even its color was a puzzle. To the human eye, it would have appeared faintly pink, but to infrared instruments, it seemed darker, cooler, almost ghost-like. The more astronomers tried to define it, the more it slipped away like a reflection in rippling water. Some called it a comet without a tail. Others, an asteroid between categories. A few dared, too, suggest it might be something artificial, a defunct probe or fragment of alien technology drifting aimlessly through the void. The debate was calm but electric, carried out through scientific papers and midnight discussions. There was no proof of life, no signal, just an object that refused to behave as nature expected. As weeks passed, Oumuamua grew fainter, receding toward the outer solar system, a drifting shadow swallowed by the dark. Telescopes followed it until even the largest mirrors could no longer see its shimmer. It was gone, leaving only equations, archived images, and the lingering feeling that something extraordinary had brushed past Earth's quiet orbit. In classrooms and observatories, scientists tried to capture what had happened. They calculated its speed, about 196,000 miles per hour relative to the Sun. They estimated its origin, perhaps from the Lyra constellation, near Vega, though its path had been distorted by interstellar tides for millions of years. Somewhere, long ago, gravity must have ejected it from its parent star system. Maybe from a planet collision, maybe from a gravitational slingshot. Whatever its beginning, it had traveled for eons through the interstellar dark, collecting dust, scars, and silence. Oumuamua's passing wasn't just a discovery, it was a realization. The solar system isn't sealed off. Objects from other suns can cross our path, whispering through the void, then vanish again. The universe, once thought to be distant and unreachable, had reached into our own backyard. And yet, even with all our instruments and equations, so much remained unspoken. Why did it accelerate? Was it outgassing invisible hydrogen? Or did its surface reflect sunlight with unusual efficiency? Perhaps shaped like a sail, thin enough to catch radiation pressure. Could it be hollow? Could it be something built, long abandoned and wandering? These questions drift like stardust through the scientific imagination, unresolved but luminous. Oumuamua, the silent visitor, gave no answers. It passed too quickly for capture, too quietly for certainty. Now, as astronomers replay those nights and re-examine the data, they notice something curious. Just 2 years later, another interstellar traveler entered our solar system, a true comet this time, bright and visible, carrying its own story. Two messengers from the deep, arriving almost together, like a whisper and an echo. And somewhere between the stars and silence, the question remains, if Oumuamua was the first to arrive, who or what might follow next? It begins the way most discoveries do, not with a thunderclap, but with a faint, trembling line of data. A small dot gliding across the silent screen of a telescope array in Hawaii, recorded one evening as the dome turned slowly under a veil of cloud. For a moment, it looked like just another comet. But then, the numbers refused to match the pattern. Its speed was too high. Its orbit was not elliptical, not even parabolic. It was hyperbolic, meaning it had not come from our sun. It was arriving from somewhere else entirely. When Oumuamua passed through our solar system in 2017, it carried that strange quality, a sense of being the first interstellar visitor we had ever seen, the first traveler from another star. Yet as astronomers watched it fade away into the outer dark, a quiet question remained. Could it truly be alone? 2 years later, the sky gave an answer. In late August 2019, telescopes caught another faint object, a blur with a long, thin trail of dust behind it. Its motion was again too fast, its orbit open-ended. Astronomers named it 2I Borisov after Gennady Borisov, the amateur astronomer, who first spotted it from his small observatory in Crimea. It was the second known interstellar object to visit our solar system, the second messenger from beyond. Unlike Oumuamua, Borisov wore a visible coma, a halo of gas and dust that trailed like a soft veil. It glowed faintly blue under the reflected sunlight, revealing the chemical fingerprints of cyanide and water vapor through spectrograph analysis. It behaved, at least at first glance, like a comet, familiar, understandable, a fragment of another system's frozen outskirts. But the timing was uncanny. Two interstellar objects appearing within just 2 human years of each other after billions of years of silence. It felt less like coincidence, more like the beginning of a whisper between stars. As the narrator's voice drifts, the story slows to let listeners imagine both travelers together. One, a dark, tumbling shard with no tail, like a blade of obsidian spinning through light. The other, a pale and misted form, trailing a soft blue haze behind it as it sails past the sun. One silent, one shimmering. They never met, separated by distance and time, yet linked by trajectory and mystery. Both followed hyperbolic paths, curves that never close, arcs that promise no return. That shape, the narrator explains, tells us something essential. A comet born within the solar system moves in an ellipse drawn by the sun's gravity, pulled back again and again. But a hyperbolic orbit means freedom. It means the visitor came from deep space, caught the sun's warmth for a moment, and then slipped back into the cold forever. The telescopes tracked Borisov as it neared perihelion, the closest point to the sun, just 2 astronomical units away, roughly the distance between Mars and our star. Its tail stretched nearly 100,000 miles, a shimmering thread reflecting the soft yellow light of dawn. Through the spectrograph's color bands, scientists detected familiar compounds, carbon monoxide, oxygen, hydrogen cyanide elements that speak of frozen origins. This wasn't alien metal or some hollow artifact. It was, in every measurable sense, a comet. Yet it was also foreign, carrying the fingerprint of another sun. In simple terms, the voice explains, comets like Borisov are the crumbs left from the building of planets. When a young star forms, its gravity stirs a disk of dust and gas around it. Some material clumps into worlds. Some drifts outward, never to return. Over millions of years, gravitational nudges from giant planets can fling those remnants into the dark between stars. Most will wander unseen forever, but a few will eventually cross paths with another system like ours. Still, for listeners, lying in bed, the thought feels more human than mathematical. You can almost picture it, a frozen traveler gliding through endless night, carrying the ancient scent of another sky. Perhaps it once orbited a blue-white star whose light has long since dimmed. Perhaps it witnessed planets forming, then burning away. For countless ages it drifted in silence, until one day, chance pulled it into our corner of the galaxy, where human eyes would finally notice it. The discovery of Borisov reignited debate. If 2 interstellar travelers appeared so close together, could there be thousands more too small, too faint for our instruments to catch? The narrator's tone softens. It's like standing by the sea, realizing that the 2 waves you see are only a hint of the countless ones beyond your horizon. Astronomers began recalculating probabilities. Maybe our solar system is crossed by interstellar visitors far more often than we knew. Maybe every decade, 1 or 2 drift quietly through the inner planets, their faint trails lost against the sun's glare. Only with new surveys, new eyes on the sky, did we finally notice And so the two objects, Oumuamua and Borisov, became twin symbols, one silent, one glowing. They reminded us that the space between stars isn't empty. It's a slow river of dust, ice, and fragments. Somewhere in that cosmic tide are the forgotten memories of countless other worlds. As the narrator's voice lowers, a poetic calm fills the air. Imagine both travelers now far beyond Neptune's orbit. Oumuamua, dim ember, tumbling toward the constellation Pegasus. Borisov, its tail long faded, drifting toward Cassiopeia. Two marks on the same vast map, fading from view, but never from wonder. In that thought lies a question, quiet as breath. If two messengers have already brushed past us, how many more cross the void unseen? How many ancient travelers pass through the cradle of our sun each century, leaving no trace but a shimmer in the dark? The music slows. The stars stretch outward. The narrator whispers one last line before silence. Perhaps the universe has always been speaking. We just needed to learn how to listen. Above the earth, the night stretches unbroken as soft canvas of deep indigo dusted with stars. Somewhere in that stillness, a telescope turns its mirrored eye toward the heavens. It moves slowly, almost imperceptibly, guided not by instinct, but by code. The dome of the observatory hums faintly, its rotation syncing with the sky. Within, rows of monitors glow in the dim light, painting quiet faces with blue reflections. These are the eyes that sweep the endless night-hour instruments, watching for the smallest flicker that says something new is here. Wide-field telescopes scan vast regions of the sky, taking pictures that overlap like the pages of an unfolding story. Each image holds billions of points of light, ancient, constant, familiar. But every so often, one of those points moves. To human eyes, the motion would be invisible. To the computers that compare night after night of exposures, it's a whisper of change, a faint pixel that refuses to stay still. That single anomaly, so small it could be a speck of dust on the sensor, might in truth be a traveler from another world. Inside the control rooms, the air is filled with soft electrical hums and the faint clicking of keyboards. Observers speak in low tones, as if unwilling to disturb the universe outside. A camera, cooled to temperatures colder than winter in Antarctica, collects photons that have journeyed millions of years through the void. Each photon is a messenger, its energy unchanged since it left the heart of some distant star. When enough of them land in just the right pattern, a new object appears, unassuming, dim, but different. Astronomers have a word for the act of noticing: detection, but the word barely captures the emotion of it. When that faint dot emerges from the data, hearts still quicken, even among those who've spent decades peering at screens. The software begins its task, calculating coordinates, comparing orbits, predicting motion. It checks catalogs to see if the object belongs, perhaps a known asteroid, a passing comet, a fragment of ice. If nothing matches, the whisper grows. Louder. Maybe, just maybe, this point of light is something new, something unbound. The story of how astronomers map the heavens is one of precision and patience. Every night, survey cameras like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona capture the same patches of sky again and again. They watch for what changes, tiny blinks, small movements against fixed constellations. Computers sift through oceans of data, flagging what doesn't belong. To find one interstellar visitor among millions of asteroids is like noticing one snowflake drifting against the wind in an endless storm. Yet somehow, we do. When an anomaly is spotted, scientists turn to mathematics. They measure its trajectory, the invisible path it traces through space. If that path curves around the sun and returns, it's bound, part of our solar family. But if it cuts through on a hyperbolic curve, never to return, it's something else entirely. Its perihelion, the point closest to the sun, becomes a moment of revelation. Sunlight warms its surface, perhaps enough to shed a faint tail of gas or dust. Or, in some cases, nothing happens at all, only silent acceleration, as if driven by forces we can't yet see. The tools used to track these motions are as elegant as they are complex. A spectrograph splits light into its rainbow of wavelengths, allowing scientists to read the chemistry of distant objects, ice, carbon, rock, or something stranger. Telescopes across the world coordinate observations, each contributing their own layer of truth. One measures speed through Doppler shift, another measures brightness. Together, they piece together the object's story. Is it rotating, tumbling, reflecting sunlight, or generating its own faint glow? Amid this dance of numbers and light, there's a profound stillness. In remote mountaintop observatories, wind hums through cables while crickets sing in the valleys below. Sometimes the astronomer steps outside the dome for a breath, looking up with unaided eyes. The same sky that cameras map so precisely still holds its old quiet magic. Even knowing the mathematics behind it, the sight of the Milky Way arching overhead feels like standing beneath a living cathedral. And yet, every discovery begins as something ordinary, a faint change in brightness, a misplaced pixel. When Oumuamua first appeared, it was nothing more than a small dot moving too quickly across frames. Only later, through calculation and comparison, did astronomers realize it was something extraordinary. The same process repeats now as new surveys comb the sky, their electronic eyes sharper and faster than ever. Each night, terabytes of images flow into servers, each image waiting for its own whisper of anomaly. But machines, for all their precision, depend on human curiosity. A computer can flag an object, but only a human can feel wonder. It's that mix of data and emotion-cold measurement wrapped in quiet awe that gives astronomy its heartbeat. The soft tapping of a keyboard becomes the rhythm of discovery. The low whir of a telescope dome, a pulse in the dark. In this chapter's quietest moments, imagine yourself there. A faint red light, the hush of machinery, a coffee cup cooling beside a console. On a monitor, a scatter of white points against black ordinary stars, patient and still. And then, one of them shifts. A single pixel slides just slightly between frames. To most, it would mean nothing. But to the watcher, it means everything. It is motion, story, and mystery all at once. What follows is the careful unfolding of truth. Calculating orbital inclination, measuring eccentricity, testing whether gravity alone explains the movement. Sometimes it does. Other times the equations leave a residue of mystery, a discrepancy, too large to ignore. That's when astronomers lean back in their chairs, eyes reflecting the faint blue of the screen, and whisper the words that fuel every new chapter of cosmic exploration. That's odd. And so, the watchers keep watching. Their instruments hum through the night, capturing the invisible ballet of comets, asteroids, and possible visitors from beyond. In every frame lies the potential for wonder. Somewhere in that silent data may already rest the next messenger, waiting for someone patient enough to notice. The domes close before dawn, sealing in the night's discoveries. The screens go dark, and the world below begins to wake. Yet above it all, the sky remains the same calm, ancient, endless. What secrets do these visitors carry on their frozen, ancient surfaces? Perhaps within each tiny spark of light, the universe keeps one more story waiting to be read. The night sky holds a kind of rhythm, steady, predictable, familiar. Comets streak by with bright tails. Asteroids drift like stones between planets, and meteor showers trace graceful arcs above the sleeping Earth. Yet, every so often, something moves differently, something that refuses to follow the usual script. That is how astronomers felt when they studied Oumuamua and the second mysterious vessel. Both objects seemed to belong to no category, each carrying an echo of the unknown. Their motions whispered of an intelligence or an accident far beyond human reach, wrapped in the calm hum of cosmic silence. Oumuamua, the first visitor, had already startled scientists with its speed and path. It wasn't orbiting the sun like a comet or asteroid. It was passing through a traveler just visiting our solar neighborhood. But its behavior didn't stop there. As it neared the sun, it began to accelerate. Not much, just slightly, yet enough to catch attention. Gravity alone couldn't explain it. There were no visible jets of gas pushing it forward, no outburst of dust that would suggest melting ice. It was as if some invisible hand had brushed it gently, sending it on its way again. The second vessel, discovered years later, was brighter and more active, more like a comet in the traditional sense. It released gas and dust, forming a faint halo that telescopes could trace as it curved around the sun. Still, even that one had peculiar traits. The way its coma shimmered in reflected starlight didn't fit the usual pattern of icy comets. It spun faster, burned differently, and defied the tidy categories of planetary science. Together, these two objects seemed to hum in harmony, a duet of cosmic questions. Imagine, for a moment, their movement from the perspective of deep space. Two small shapes gliding through darkness, brushed by solar wind, surrounded by nothing but starlight and silence. Oumuamua tumbled end over end, catching sunlight in flashes that rose and dimmed like the blink of a distant lighthouse. Its surface reflected light metallic rock smooth, almost mirror-like. Yet spectrographs revealed nothing certain. No metal signature, no clear ice, no familiar trace. It was as if it had been sculpted by processes unknown to us, or perhaps eroded by time in ways we can't yet reproduce. Astronomers debated. Could radiation pressure from sunlight itself have nudged Oumuamua forward? When photons, tiny packets of light, strike a surface, they exert a minuscule push. For a thin, broad structure, like a sail, that push could build into measurable acceleration. If Oumuamua were just a few millimeters thick, like metallic foil, that might explain the motion. But natural objects rarely take such shapes. Comets are rounded, fractured, messy. Asteroids are dense and lumpy. Nothing in our own solar system matches that smooth, elongated form. Others suggested outgassing. Perhaps Oumuamua released invisible jets of hydrogen that we couldn't see, remnants of long frozen ice, turned to gas by solar heat. But even that theory stumbled. The jets would have caused rotation changes that weren't observed. The more scientists looked, the stranger the story became. In the quiet of observatories from Hawaii to Chile, data flickered across screens like faint whispers from the cosmos numbers that didn't add up. Traces that hinted at something else hiding beneath the surface of understanding. The second visitor, by contrast, seemed to play by more familiar rules. It was officially cataloged as a comet, one of the few confirmed interstellar comets ever found. It glowed softly, releasing vapors of cyanide and carbon monoxide as it drew near the sun. Yet its trajectory mirrored Oumuamua's too closely to feel random. Two interstellar travelers, both detected within a few short years, both arriving from distant regions beyond the local star cloud. It was like hearing two distinct notes of the same melody after eons of silence. Coincidence, perhaps, but to astronomers, coincidence is the mother of curiosity. Night after night, telescopes tracked these faint anomalies against the black canvas of space. Observers described them in calm tones, one accelerating, one outgassing, both fleeting. But under those words was a quiet wonder, a feeling that nature might be hinting at a larger pattern. Maybe interstellar objects pass through more often than we realize, most too dim to notice. Or maybe these two were different messengers of something rare, perhaps even purposeful, gliding unseen through the cradle of our solar system. In the soft glow of computer screens, scientists replayed their trajectories like slow dances. They mapped out their paths, curved lines looping by the sun, bending and escaping again toward the stars. Each orbit was precise, each vector beautiful. Yet what unsettled them was not what they could see, it was what they couldn't. The small unexplained acceleration, the missing tail, the surface that looked metallic but wasn't. Every anomaly became a small puzzle piece with no matching edge. The narrator's tone remains gentle, lulling listeners toward the rhythm of these discoveries. The words solar wind and radiation pressure drift through the air like the hum of far-off machinery. Each term is softened by imagery. The solar wind as a slow river of particles. Radiation pressure as a whisper of light pressing on ancient skin. Science and poetry meet in the middle, turning uncertainty into music. Listeners are reminded that science often begins with questions, not answers. What we call a century ago, people called meteors. Divine fire. Now we know them as rocks. Perhaps a century from now, our descendants will understand Oumuamua's true nature with the same simplicity. Or perhaps it will remain a myth, our generation's quiet legend written in starlight. In this calm retelling, there is no fear, only awe. The sky above is a vast library of mysteries, and every comet, asteroid, or unknown traveler is a sentence written across it. Oumuamua and its twin have become chapters in that eternal book, their movements described not just by equations, but by the hush they leave behind. As you imagine these travelers drifting through the sun's light, you can almost hear the faint hum of motion, like a breath in the darkness. The stars shimmer, and in that silence, not act like the ones we know. Perhaps they are trying to tell us a story we have not yet learned how to read. The glow fades, the data streams quiet, and the universe waits patient, endless, holding its secrets within the light. In the calm darkness between the stars, the story widens. The narrator's voice slows to a whisper, describing a universe in motion, a place where new suns are born in clouds of dust and gas, and chaos gives birth to order. Picture a young star system, still glowing with the heat of creation. Around it, millions of fragments spiral through the haze, boulders of ice, metal, and carbon, colliding, merging, and breaking apart. It is a cosmic nursery, both violent and beautiful. Gravity is the sculptor here, pulling stray particles into planets and moons while the rest are flung away, rejected children of formation, hurled into the dark. These are the first interstellar travelers, silent wanderers that will drift for eons before meeting another sun. Astronomers call this process planetary ejection. In every newborn system, countless bodies are thrown beyond the reach of their parent star. Some are small, like icy shards of forgotten comets. Others are massive failed worlds that once dreamed of becoming planets. They travel at astonishing speeds, following no orbit, no map, no master. One of these could have been Oumuamua. Another, the second vessel that entered our solar system fragments cast adrift from faraway suns. Each one carries the fingerprint of its birthplace, like cosmic fossils sealed in darkness. Through the narrator's gentle tone, listeners are guided across the galaxy, through swirling nebulae that shimmer in blues and golds, through clusters where newborn stars blaze in tight constellations, and through regions where old stars fade, like dying embers. Here, in the quiet outskirts, countless objects wander. They are not bound by gravity anymore. They belong to no system, free, fragile, timeless. Some may drift for billions of years, brushing past unseen planets, grazing the edges of invisible magnetic fields. They do not age, they do not erode. They simply move, carrying the memory of suns that once warmed them. In a way, every ejected fragment is a message in motion, a natural postcard from a distant world. Its minerals and ice hold chemical stories of alien skies and forgotten storms. When one of these travelers passes near us, our telescopes act like readers of this interstellar mail, decoding light and color, searching for clues in reflected starlight. The narrator explains how each spectral line, every faint signature on a telescope's graph, is a whisper from another system. Sometimes the signal is faint, barely distinguishable from background noise. Yet even that silence feels full of meaning. Listeners can imagine scientists on Earth watching through glass domes under the soft hum of machinery. They trace orbits and trajectories, realizing how lucky we are to witness even two such travelers in a single lifetime. In the scale of galactic time, that's like catching two leaves from different trees floating down the same river. The chances are almost impossible, and yet, here they are. Our solar system, vast yet small in the cosmic ocean, becomes a brief harbor for these ancient visitors. The narrator's voice grows quieter, almost like a lullaby. Maybe, it says, the universe shares its memories this way. Each ejected fragment becomes a storyteller, drifting across the void, carrying tales of how stars are born, how planets fail, how worlds scatter. It's a comforting thought that even in cosmic chaos, beauty emerges through motion and distance. We are not only watching rocks, we are glimpsing history written in orbit and silence. Yet, as the calm deepens, another thought lingers. The paths of these objects are random, but sometimes they seem too precise, their timing too synchronized. Oumuamua's arrival, followed so soon by the second vessel, feels less like accident and more like rhythm. Could there be an unseen harmony in the way the galaxy casts out its travelers? Or could there be intended design woven into what looks like disorder? The music fades beneath the narration, leaving the listener in quiet reflection. The sky above Earth is full of drifting shadows, ancient travelers from distant suns, each one carrying a frozen memory of creation. Perhaps most are just fragments of chance, but some details, some patterns, still feel carefully arranged, as if the universe itself is composing a secret message. And in that stillness, as starlight spreads across the cradle of silence, one can almost sense that something else is moving in the dark, something waiting to be understood. ChatGPT can make mistakes. Check important info. Under the velvet silence of deep space, two faint travelers drift through the solar system, Oumuamua and its mysterious successor. To most astronomers, they are simply fragments of other worlds. Shards of ice and stone, thrown loose from their birth stars long before Earth had oceans. Their paths through the void are governed by gravity alone, shaped by the same cosmic ballet that guides comets, asteroids, and dust. In the soft language of physics, they are natural debris, unbound and eternal, passing through like forgotten embers. But even in the calm confidence of scientific explanation, there lingers a tremor of curiosity. Oumuamua, with its strange shape and subtle acceleration, broke quiet assumptions. No comet tail, no plume of gas, no familiar glow. It slipped past the sun like a blade of glass catching faint starlight, then vanished beyond our telescopes. The second vessel, slower, brighter, more comet-like, followed only years later. Two visitors, both from the deep, each carrying silence thicker than mathematics could explain. Astronomers began to wonder, softly, cautiously. Could nature alone craft such precision? Could coincidence explain the timing of their arrivals to interstellar bodies discovered within the brief breath of a decade? Some said yes. The galaxy is vast, and billions of rogue objects wander unseen. Others tilted their heads toward the dark and whispered, perhaps the pattern means something more. The narrator's voice slows, almost like a lullaby. In the gentle half-light of imagination, another possibility emerges not as a declaration, but as a dream. What if some of these travelers are relics, not rocks? Ancient tools or vessels launched by civilizations long extinct, their creators long dissolved into the dust of their own dying suns. Picture a light sail, a wafer-thin sheet, glimmering against starlight, drifting endlessly on the pressure of photons. No engines, no signals, just motion. Such a device could cross interstellar space without power, surviving millions of years silent, durable, and easily mistaken for an oddly shaped asteroid. In that stillness, a metallic glint could be lost among ordinary stones, and a message could pass by unnoticed, written in the faint language of trajectory and reflection. The thought is neither fearful nor grandiose. It's tender, almost human. Maybe these are not emissaries of danger, but souvenirs of curiosity. Tools forgotten by their makers, drifting between galaxies like messages in cosmic bottles. A civilization might once have looked outward as we do now, sending out instruments into the unknown Voyager, Pioneer. New horizons all destined to become quiet messengers of our existence. Perhaps somewhere else, another species did the same, long before our own beginnings. If so, what happens when such relics reach us? They do not knock. They do not call. They pass silently, offering no clue except the whisper of altered motion and the shimmer of an unfamiliar shape. Our telescopes, like open palms, try to catch their stories, but the fragments slip through our grasp, leaving only questions. Scientists continue to seek comfort in probability. They simulate ejections from distant suns, count gravitational slings, and predict how billions of small fragments wander through interstellar space. Yet even in their models, an edge of strangeness remains. Oumuamua's spin, its flatness, its brightness, each one nudges gently against expectation, as though nature, patient and ancient, still knows how to surprise the mind that studies it. And still, beneath the equations, a softer question lingers. Why do we want these objects to be something more? The idea of an artifact, a silent messenger, a trace of intelligence, touches something ancient in us. The desire not to be alone. The need for meaning among the stars. The narrator invites you to imagine standing under a midnight sky, the air cool and still. Overhead, an invisible traveler passes through that same darkness, its path unseen but real, its journey unending. Maybe it's nothing more than cosmic rubble. Maybe it's something once made by hands like ours hands now turned to dust under another sun. The truth remains hidden, wrapped in silence and light. Every possibility hums quietly in the space between certainty and wonder. Natural debris or silent messengers. The distinction fades when viewed from such distance. Both are part of the same cosmic memory, fragments of creation drifting in a cradle of silence. As the music of the universe resumes its slow rhythm, one thought glimmers faintly before the light fades. Perhaps every traveler we meet in the dark carries not a warning, but a reflection of ourselves, proof that even across endless night, curiosity endures. And somewhere out there, beyond the last flicker of our telescopes, something unseen continues to drift steady, silent, timeless, waiting for eyes patient enough to notice its passing. In the cradle of silence that hangs between planets, where light takes hours to cross the space between worlds, a faint pattern begins to emerge. It isn't a flash or a transmission, not a coded sequence of ones and zeros, but motion itself. The universe, after all, has always spoken in movement. Stars orbit, planets turn, comets drift in long, patient ellipses. Yet every so often, something passes through that does not belong. A traveler on a hyperbolic trajectory, coming from nowhere, leaving toward nowhere. To the human eye, it is just a streak against the soft glow of starlight, but to the sensitive instruments of our age, it is a whisperous signal without sound. Scientists once imagined that if other civilizations reached out, they would do it through language or radio, a clear beam of intent cutting through the dark. But what if messages can exist in form alone? The orbit, the spin, the strange acceleration of an object, each could be a sentence in a language we have not yet learned to read. When Oumuamua slid through the solar system, its path was strange enough to demand explanation. Then another visitor followed. To some, it was just coincidence. To others, an echo, a quiet rhythm across cosmic time. Astronomers began to notice a pattern hidden in their data. The first traveler, long and thin, tumbled as if it were reflecting light unevenly, suggesting a flattened shape, almost like a shard of metal or a sail. The second, rounder and trailing a ghostly veil of gas, behaved like a comet, yet its chemistry was unlike any seen before. Their trajectories crossed the inner solar system only a few years apart, both coming from different corners of interstellar space, both leaving behind the same question: what are the odds? In observatories high above clouds, telescopes turned toward the darkness, watching for motion. Inside, computers hummed softly, translating faint shifts in starlight into position and speed. When a tiny dot moves against the background stars, astronomers can measure its orbit. If that orbit bends in a perfect parabola, the object is bound to the sun. But if it arcs in a hyperbola, never looping back, that object is free, unchained from another world. Each new detection is plotted on a glowing screen, a map of moving lights, some familiar, some utterly alien. There's a kind of music in this data, though we rarely hear it. The rhythm of the cosmos is slow, one orbit in centuries, one encounter in millennia. Yet every variable velocity, inclination, rotation, becomes a note in a song that plays too softly for ears to detect. It's possible, perhaps, that we're only beginning to recognize the melody. Not all signals need to be sound. A gesture, a pattern, a recurring motion could speak volumes to those who know how to watch. When scientists searched for radio signals from Oumuamua, the deep space arrays listened intently. They heard only silence, no pulse, no hum, no artificial transmission. But in that silence, another kind of story formed. The object's small but measurable acceleration near the sun defied simple gravity. Some called it a comet outgassing invisible hydrogen. Others whispered about light pressure, a possible hint of technology. Most scientists favored natural causes, but even they admitted the truth was faint, hidden under layers of distance and dust. Imagine standing under a night sky far from cities, where the Milky Way spills across the black. Somewhere out there, invisible to your eyes, but real in the numbers of astronomers' screens, another object is moving, a tiny glint drifting through starlight. No radio chatter, no visible signal. Yet it's traveling at a speed and angle that make no sense for a random fragment. Its arrival is like finding a message in a bottle on a deserted beach. Except the ocean is the galaxy, and the message is written in motion. Scientists sometimes describe these trajectories as messengers of chaos, remnants flung from collapsing systems or dying stars. Others think of them as carriers of knowledge, even if accidental, tiny archives of chemistry and time. Each fragment holds clues to the materials that built distant worlds. Spectrographs decode their surfaces, revealing traces of carbon, metal, and ice ingredients older than the Earth itself. Yet the mystery remains. Why do some accelerate as if guided by a force we can't see? In the quiet hours of night, when observatories grow still, one can almost sense the universe breathing. There is no sound, no wind, only the data stream whispering in light years per second. A pulse appears, then fades. Another dot shifts slightly, off its predicted course. Astronomers record it, chart it, and watch as it fades into the dark. To them, every movement could be a conversation, one that spans distances so vast that silence itself becomes part of the dialogue. Perhaps the universe never meant to hide anything. Maybe the signals were always there, written in the choreography of comets and the dance of dust. Humanity, still young and learning, is only now learning to interpret them. A pattern of arrivals, a cluster of alignments, a forbidden curve bending just so near our sun. It all feels intentional, even if it's not. The cosmos may be tracing shapes in the void, drawing with light instead of ink. And in that quiet, where telescopes wait and the sky remains still, there's a feeling that we're on the verge of understanding something. Something that doesn't speak in words or frequencies, but in presence. Two travelers have already brushed past us, their silence louder than any signal. Somewhere, out beyond the orbit of Neptune, another glint might already be on its way. The data fades, the stars resume their steady glow, and the universe hums. Unvast, indifferent, and yet strangely intimate. The silence deepens, yet hidden in that silence is something waiting to be understood. In the beginning, before telescopes and equations, there were only eyes, human eyes, gazing upward into the endless dark. Long before astronomers learned to measure orbits or predict trajectories, people stood in open fields, on ship decks, or at temple gates and saw something strass the night sky, a glowing tail, a streak of light that did not belong to the steady rhythm of the stars. The sight filled them with a mix of awe and dread. A comet was never just a rock to them. It was a messenger, a harbinger, a cosmic whisper hinting that something on Earth was about to change. Imagine a quiet village thousands of years ago. The air is still. Children sleep. Then a shout breaks the silence. Someone has seen it. Blazing form with a soft, wavering tail, like smoke painted across the heavens. People rush out to watch, their faces pale in the silver glow dot to them. The universe has spoken, though no one yet knows the language. The comet's light is beautiful, but its meaning feels heavy, as if fate itself is hanging in the air. Across ancient China, scribes would record each appearance carefully, linking the visitor in the sky to events below famine, the fall of an emperor, the death of a ruler. In Greece, philosophers called comets burning stars, wandering omens that mocked divine displeasure. In Europe's medieval nights, priests warned that such fires foretold plague and punishment. Sailors at sea whispered prayers, believing that the bright tails pointed toward death or safe harbor, depending on the god's mood. But in every age, amid the fear, there was also wonder. The same shimmering light that terrified one person inspired another. Artists painted it, poets sang of it, and astronomers began to question, why should the heavens send signs at all? The narrator's tone softens as if speaking beside a campfire. Perhaps, it says, the universe never meant to frighten us. Perhaps it was only moving, as it always had, quietly, beautifully, indifferent to our fears. Centuries later, science gave these glowing visitors new names and calm explanations. What was once a curse became chemistry, ice and dust, orbiting remnants of creation. The word comet began to sound less like a warning and more like a lullaby. Scientists learned about perihelion, the moment a comet swings closest to the sun, shedding a luminous veil of vapor and gas under the solar wind. Through telescopes and spectrographs, their tails revealed sodium, carbon, and water. No prophecy, only physics. Still, something ancient lingers in us. Even now, when a bright comet crosses the modern sky, people gather outside and stare, quiet, breathless. Phones record, telescopes align, but inside that collective silence lives the same pulse of emotion that guided our ancestors. Wonder and fear, awe and smallness. the fragile sense that we are part of something vast, timeless, and mysterious. When Oumuamua arrived, it reawakened that old instinct. Those scientists spoke of hyperbolic trajectories and radiation, not its soul. The rest belongs to imagination, to the part of us that looks but numbers and wonders what else might be waiting in the dark. The hum of computers fades, replaced by the soft rhythm of the Earth turning. Somewhere another. Telescope awakens, lenses clearing, ready to capture the faint glimmer of the next unknown traveler. The light will arrive, the data will come, and for a moment, we will believe we've caught the truth itself until it slips again, deeper into mystery. And in that drifting quiet, one can almost sense that another secret was about to reveal itself. The night sky has always been a slow-moving map, constant, familiar, serene. Yet hidden in that apparent stillness are travelers no human eye has ever caught. The new generation of telescopes is being built to change that, to see everything, even the faintest shadows slipping across the starlight. Imagine a camera so wide it can photograph the whole sky every few nights, layer upon layer, building a living film of the universe in motion. Every sparkle, every blur, every shifting pixel could be a visitor from another star. In quiet mountaintop observatories and dry desert plains, engineers assembled the next watchers. The Vera C. Rubin Observatory in Chile, the Roman Space Telescope preparing to unfurl above the atmosphere, and networks of survey arrays that never sleep. Their lenses will not blink. Each night, they will breathe in starlight and exhale data petabytes of motion, brightness, and silence. Computers will sift through those patterns like dream catchers, finding the flickers that don't belong, the tiny dots that move just a little too fast or fall from an orbit no planet claims. In the calm darkness of the control rooms, the hum of cooling fans replaces the human heartbeat. Technicians whisper across radio channels, waiting for a speck of light that wasn't there before. Sometimes it will be a piece of human debris, a lost satellite, a drifting panel of foil. Sometimes it will be a near-Earth asteroid, small and harmless, visiting close before fading back into the void. But every now and then, one of these dots will arrive with an impossible orbit, a speed that cannot be born of our sun. These are the ones that make scientists lean closer, hearts beating a little faster even in the hush of the midnight shift. The narrator's tone softens, guiding the listener through the rhythm of this cosmic surveillance. Each survey image is like a breath, the universe inhaling and exhaling light. Over weeks, the sky becomes a time-lapse dream. The Milky Way turns, nebulae shimmer faintly at the edge of detection, and through it all, the watchers wait for a single motion that breaks the pattern, a drifting shard from a distant supernova, an ancient traveler of ice and dust, or something else entirely. When Oumuamua first appeared, it came and went before we even realized it was interstellar. By the time the telescopes turned their full gaze, it was already fading, swallowed by distance. But the next watchers will not miss the second arrival. Their algorithms are taught to listen for anomalies, the strange curve of a trajectory, the whisper of an orbit that doesn't fit gravity's usual map. Some of these instruments will even be able to pivot automatically, pointing their mirrors at a newly found traveler within minutes, catching its first glimmer before it's gone again. Imagine standing beneath such a sky, knowing that somewhere above, invisible yet near, a vast mechanical eye is always open. Its mirrors gleam with a soft glow, like the calm surface of a lake catching moonlight. You can almost hear the faint clicks as it captures another frame, another whisper from space. These machines are not replacing wonder, they are recording it, translating mystery into pixels that still manage to feel infinite. The narrator pauses, letting the quiet expand. In this cradle of silence, the idea feels strangely intimate. The universe is being watched not by a single human gaze, but but by a collective of lenses, sensors, and minds. Across continents and oceans, data flows like rivers of light radio waves from desert dishes, infrared images from high-altitude balloons, and faint spectrographs from deep-sea fiber lines connecting observatories. All of it feeding a single purpose: to know when something from the outside enters our sky again. Perhaps the next visitor will not come alone. Perhaps the surveys will reveal a caravan of faint objects, like a silent flotilla moving through the outer solar system, each reflecting just enough light to whisper, "I am here." Or maybe we will find smaller, more fragile shards, tiny echoes of worlds long gone, frozen memories still carrying the chemical fingerprints of alien suns. For a moment, the narrator invites the listener to imagine the sensation of discovery itself. A faint pixel appears on the observer's monitor, blinking softly against the black. It wasn't there last night. The algorithm hesitates, flags it, and then confirmation. Its orbit is hyperbolic, not bound to our sun. Another unknown traveler has arrived. Somewhere, a scientist leans back, closes tired eyes, and smiles. The waiting was worth it. These watchers, machines built by human hands, will outlive their creators. Long after today's astronomers are gone, the telescopes will still stare, still gather the faint whispers of motion that drift across the darkness. The universe will continue sending its quiet guests, and our instruments will continue to listen. The narrator's voice fades into a soft reflection. The idea of more interstellar visitors no longer feels frightening or even rare. It feels inevitable. It feels inevitable. Just as the sea always sends new waves to the shore, the galaxy will send new travelers through our sky, each a small reminder that we are part of something much larger, much older, and still unfolding. The chapter closes on a tranquil image. A slow camera shutter opening once more, light spilling across the lens like a gentle dawn. Somewhere in that image may already be another dot, another story waiting to begin. The silence deepens, yet hidden in that silence is something waiting to be understood. It begins in silence so deep that it feels like sound has never existed. Through the black velvet of interstellar space, a small traveler drifts, carried only by motion older than memory. No engines, no course corrections, no crew. Just momentum, gravity, and the faint pressure of light itself, the solar wind pushing gently against its scarred surface. The object spins slowly, a frozen relic of a forgotten system, its skin marked by billions of years of dust collisions and ancient fractures sealed by cold. As it floats through the emptiness, the narrator invites you to imagine riding beside it. The stars around you do not move. They shimmer in every direction, fixed in their distant brilliance. Ahead, the faint blue haze of the Milky Way stretches like a soft veil across the darkness. The traveler passes drifting clouds of gas nebulae glowing in pale crimson and turquoise, the quiet afterbirth of dead stars. Through these regions, dust clings briefly to its surface, like pollen to a passing wing, before the next pulse of cosmic wind sends it onward. Somewhere behind, a pulsar beats with a steady rhythm, a cosmic clock ticking across light years. The traveler is indifferent. It has no eyes to see or ears to hear. Yet, if you could feel what it feels, you'd sense tiny vibrations running through its crust each time it crosses invisible rivers of charged particles. The solar wind hums a soundless whisper, pressing just enough to change its path by fractions of a degree. Its journey began long before the sun existed, ejected from a collapsing disk around some distant star. Perhaps it was once part of a planet that shattered during a violent collision, or a chunk of ice ripped from the edge of a forming moon. Whatever its origin, it has been alone for tens of millions of years, crossing the cold void between galaxies, through stretches where not a single atom exists per cubic meter. Now, for the first time in its long existence, it approaches a star. Bright enough to cast a shadow again. From a distance of billions of miles, the sun appears as a golden ember, growing larger with each passing week. Radiation warms one side of the traveler, causing faint jets of sublimated gas to whisper from microscopic pores. Those subtle releases alter its course, tiny invisible corrections written by heat and time. As it drifts closer, telescopes on Earth catch its faint shimmer. Astronomers watch the anomaly accelerate slightly. Puzzled. No cometary tail, no plume, yet its motion defies pure gravity. To them, it is a mystery, a point of light among millions, slipping silently across the spectrograph's field. But here, floating beside it, the view is more intimate. Sunlight begins to scatter across its surface, revealing colors: dusky, red, iron gray, and streaks of pale gold from mineral veins exposed by impact. The light refracts through icy crystals like faint sparks, vanishing instantly into the void. At perihelion, the closest point to the sun, the traveler reaches its peak velocity. It moves faster than any human-made probe, faster than the solar wind itself, carving a perfect curve through invisible space-time geometry. For a few brief days, it becomes part of our solar symphony, a silent note joining planets, comets, and the steady pulse of solar radiation. Then, the arc bends outward once more. From the window of imagination, you see the sun shrinking behind, the planets turning to pale specks again. The traveler has taken nothing, left nothing. Its surface holds no writing, no signal, only the patient record of heat, impact, and light. Yet its presence changes us. By existing, it reminds us that the universe is not static. It is alive with motion, with visitors passing unseen through the endless night. Even as the traveler retreats into darkness, it continues to glow faintly in the distance, a soft echo of sunlight fading into black. For millions of years, it will drift again, crossing the quiet spaces between stars. Somewhere out there, other travelers like it glide through their own invisible lanes, unseen but constant. And if one night you look up and wonder what stories lie beyond the reach of our telescopes, imagine this: somewhere, far beyond sight, that same traveler still rides the solar wind. It carries no destination, no mission. Only the memory of warmth, the touch of a star, and a trajectory that never ends. In the cradle of silence, it vanishes once more, its light swallowed by the dark, but within that fading trace lingers a quiet question. How much of the universe has already passed us by, unseen, still traveling toward nowhere, yet forever whispering that we were never alone? ChatGPT can make mistakes. Check important info. The night opens with quiet breath, no rush, no urgency. Just the endless sky above, wide and waiting. Far from the warmth of cities, where the hum of traffic fades and only the wind speaks, a car from the warmth of cities. Faint light drifts through the dark. It is not a plane or a star, but something older, something moving with purpose, or maybe with none at all. It crosses the sky like a thought you can almost remember, but not quite hold. The narrator's voice floats with it, calm and low. These visitors, Oumuamua, Borisov, and the countless unnamed, do not come to deliver messages. Yet, somehow, they still speak to us. When we name them messengers, vessels, or travelers, we reveal something about ourselves. In every orbit we track, in every anomaly we analyze, we are really searching for reflection, for proof that our loneliness isn't the only thing moving through space. The telescopes may be machines of glass and steel, but behind each one is a human heart, staring upward with the same quiet hunger that filled the first stargazers thousands of years ago. Beneath the numbers and data, astronomy is still a mirror of longing. Imagine lying on a rooftop tonight, wrapped in the thin chill of early morning. The world below is asleep. Only your breathing and the rustle of the wind exist. Above you, a soft glow slides past the stars. Slow, silent, sure. You don't know if it's a comet, an asteroid, or a shard of something once alive. But in that fragile motion, you sense kinship. It's as if the universe has exhaled a sigh you can finally hear. Our ancestors once thought comets were divine warnings or signs of coming change. They gave them names drawn from gods, beasts, and myths, not because they knew what they were, but because they wanted to believe the sky was aware of them. We still do this, though our words are wrapped in science. We call a rock an interstellar messenger. We search its spectrum for traces of metal or water, as though decoding a letter meant for us. In truth, we are writing the message ourselves. The human mind is wired for story. Random paths through the heavens become journeys. Trajectories become intentions. A tumbling fragment of ice becomes an envoy. The unknown traveler becomes, in our imagination, a symbol or reflection of our own restlessness, our own search for meaning in the dark. We fill silence with dreams and call it discovery. Perhaps that is why these objects comfort us. They remind us that the universe still moves, still surprises. When a strange light passes through the solar system, we feel seen, even if it's only by chance. The cold mathematics of gravity transforms into something emotional, almost intimate. It's as if the cosmos reached out, not to threaten or warn, but simply to remind us, you are part of this vastness too. In observatories across the world, scientists speak softly under dim red lights. They measure angles, refine models, check the data from spectrographs. Yet even here, amid the numbers, there's a hush that feels sacred. When they find something unexplained, an acceleration too small, a shape too strange, it stirs not just curiosity, but wonder. What if this anomaly isn't just error, but invitation? The narrator's voice slows, as though tracing the orbit of thought itself. Maybe these travelers are not messages at all, but mirrors. They reflect our desire to connect, our habit of assigning purpose to chaos. We see them as lonely because we fear our own isolation. We call them ancient because we long for timelessness. We imagine intelligence because we ache for conversation. Each faint glow crossing the sky becomes a projection of who we are and what we're missing. In the cradle of silence, the stars look back without judgment. They simply exist, endless and patient, waiting for us to notice. The question, are we alone? Echoes softly through the void, but maybe the answer has been beside us all along. Hidden in our asking. The need to know, to search, to hope. Those are the signals we send into space without realizing. For a moment, imagine the universe not as an empty stage, but as a living memory. Every particle, every photon of light that reaches your eyes has traveled billions of years to arrive here, to tell its part of an ancient story. You are in this quiet moment, both observer and participant. The unknown traveler streaking across. The sky is not apart from you. It's the same stardust, shaped differently, wandering for reasons we cannot yet name. As the music softens, the tone shifts from mystery to tenderness. The narrator's words dissolve into imagery waves of light, rolling across the dark, echoes fading into sleep. The lonely visitor continues its slow escape, fading from our telescopes but not from our imagination. It leaves behind no signal, no message, no proof, only a reflection of our own longing. And somewhere beyond the edge of vision, the second vessel continues on its path, silent, patient, eternal. In its gliding shadow, one quiet truth remains. The universe has always been speaking. We are only just learning how to listen. The solar system drifts through the galaxy like a gentle harbor in motion, a circle of quiet light amid an ocean of endless night. The sun burns at its center, not as a violent star, but as a soft furnace, its glow reaching outward like lanterns. On a foggy pier, around it, the planets move in steady orbits, each one a dock of stone, gas and ice spinning through the void with calm precision. Beyond them, at the farthest edges where sunlight fades into shadow, lies the open sea, the interstellar gulf where travelers like Oumuamua and the second mysterious vessel have sailed through, never stopping, never anchoring. The narrator's voice is steady, the tone a whisper wrapped in cosmic
wonder. The solar system is described not as a fortress of rock and fire, but as a harbor, an open circle in the dark where travelers may pause for a fleeting moment before continuing their journey. The planets are like silent guards, orbiting in rhythm, keeping the pattern steady, maintaining the illusion of safety. The sun hums softly in the background, its light stretching outward, like a beacon for anyone passing by. And then the thought arises, perhaps the universe itself is built like this, a network of harbors and fortresses, open doors and guarded gates. Every star system could be a resting place or a checkpoint, or perhaps a warning zone, depending on who travels by. To a fragment of ice and rock flung from a distant exoplanet, our sun is just another warm light along a long and lonely road. But to an intelligent civilization, if one exists beyond the quiet, our solar system might appear differently. Imagine them watching from a distance, not with eyes, but with sensors tuned to the faint heartbeat of a yellow star, the slight wobble of its planets, the radio murmurs escaping from one small blue world. Would they see a fortress, a system teeming with energy and life, fiercely guarded by radiation belts, asteroids, and storms? Or would they see a harbor, an open and welcoming place, an oasis in the cold? The idea feels humbling. In the vastness of our galaxy, where billions of suns float like glowing islands, our solar system is neither unique nor empty. It is part of a cosmic archipelago, where each harbor has its own rhythm, its own defenses, its own invisible rules. Some are surrounded by dense asteroid belts like stone walls. Others lie open, easy to pass through. Perhaps Oumuamua and its twin traveler were not anomalies at all, but wanderers following invisible trade routes of gravity, pulled between stars by ancient trajectories written before humanity even existed. The narrator lingers on the image of the second vessel, its slow, smooth path through the sun's gravitational field. It did not crash. It did not stay. It simply passed through, like a guest who pauses at the doorway to listen, then continues into the night. Scientists tracked its trajectory and called it natural. Others saw in it the rhythm of something purposeful. But both views share a truth. It came from elsewhere, and it left behind questions like footprints in sand before the tide. Now imagine each solar system as a kind of fortress in its own right. The outer gas giants, Jupiter, Saturn, Neptune, act as sentinels, their massive gravity fields protecting the inner worlds from countless comets and asteroids. These natural fortresses make life possible on fragile planets like Earth. But beyond those shields, the open dark beckons, a gateway leading into interstellar space. Beyond the heliopause, the sun's influence fades, and the whispers of other stars begin to mingle with the hum of the cosmic wind. The narrator pauses, letting the silence stretch. The idea that our solar system could be both harbor and fortress is not contradiction. It is balance. A place both safe and exposed. Perhaps every civilization that rises must decide, will it remain in its harbor, building walls against the dark, or open its doors and sail outward? In soft tones, the story recalls our earliest explorers, sailors who left the safety of familiar shores to cross oceans they barely understood. They carried maps drawn from imagination and courage more than data. In a sense, our telescopes are the same, fragile instruments pointed into the deep, sketching faint outlines of the unknown. When humanity launches probes, Voyager, Pioneer, New Horizons, they become like small boats leaving the harbor's edge, their trajectories curving toward the open sea of the galaxy. Somewhere out there, one of them might drift past another harbor, unseen by us but perhaps noticed by someone else. The imagery grows quieter, dreamlike. The sun flickers at the center of the frame, its light spilling across planetary rings and icy moons. The Milky Way unfolds behind it, a silver ribbon of dust and stars. The second vessel, faint and tumbling, moves through that light like a ghost ship, silent, indifferent, beautiful. It doesn't need a destination, its motion itself is the message. If advanced civilizations travel between stars, they might have learned to use these harbors as stepping stones, a galactic network of waypoints powered by gravity and starlight. Some systems could serve as fuel depots. Others, like ours, might simply be places to observe. Maybe every time one of these interstellar objects passes through, it's part of a pattern, an ancient route designed not for conquest but for curiosity. And yet, the narrator reminds, the most fascinating part is how unaware we are of our own position. To us, the sun feels like the center of everything. But from the galactic perspective, we are a mere flicker on the outer spiral arm, a small, quiet port lit by a single yellow lamp. Our harbor might be invisible to most travelers, our signals too faint, our defenses too primitive to notice. The soft hum of the score deepens. If we are a harbor, the narrator whispers, then our purpose may not be to guard but to guide. We send out signals, light and motion, our own version of a beacon. Each mission, each telescope, each story like this one is a lantern against the vast dark, hoping to be seen, or simply to light the path for whoever comes next. And as the cosmic current flows past, the image of the solar system fades, no longer just a fortress of rock and radiation, but an open door in the quiet sea of the Milky Way. Oumuamua, the second vessel, and countless others may pass through this gateway without a word, leaving behind only trails of faint light and unanswered questions. In the gentle silence that follows, the voice softens into its final thought. Perhaps the universe isn't divided into harbors and fortresses at all, only into those who are still waiting and those who have already sailed. For thousands of years, the night sky was our oldest stage. Every spark and shimmer above seemed alive, deliberate, and full of meaning. Long before the hum of machines or the whisper of telescopes, people watched streaks of fire cross the heavens and gave them names drawn from fear and faith. In ancient China, a meteor meant the fall of an emperor. In medieval Europe, it was a sign of divine anger. Across deserts, islands, and forests, humans gazed upward, believing each fiery line was a message, an omen from the gods, a warning or a blessing cloaked in flame. Yet, beneath the myths, the truth was always silent physics. Tiny fragments of stone and ice striking our atmosphere, burning into beauty as air turned to fire around them. Still, those myths mattered. They were how our species made sense of wonder. Around each campfire, in every old story, the same question glowed quietly: what is falling toward us, and why now? When telescopes were born, the myths began to evolve. The 17th century gave us lenses that bent light instead of prayer. Galileo's hands trembled as he turned his crude tube toward the stars, revealing moons, craters, and dust that shattered the old heavenly perfection. Meteors were no longer spirits, they were matter, real and measurable. The divine veil began to lift, and behind it lay something even more astonishing: order within chaos. By the 19th century, scientists learned that meteorites sometimes survived their fall. They studied their weight, their iron, the fusion crust that spoke of violent entry. Each fragment became a fossil from the sky. And soon, the first comets were mapped, their long drifting tails plotted against the quiet geometry of the solar system. With orbit and trajectory, the language of myth was translated into mathematics. Still, even then, wonder remained. When astronomers like Edmund Halley predicted the return of his namesake comet, it wasn't just science, it was prophecy reborn through numbers. People still gathered on rooftops to watch it, still whispered wishes and fears as the bright plume returned on schedule, obedient to equations written centuries earlier. Knowledge didn't erase awe, it refined it. Then came the modern age, the humming observatories on mountaintops, the vast networks of telescopes scanning the heavens every night. The streaks we once called omens became data points, their orbits tracked and catalogued, their velocities measured to the meter per second. But as technology revealed more, the mystery deepened again. Because not every object behaved as expected. Some arrived from the far dark between stars. Oumuamua, the first to visit, spun too fast, reflected light too strangely. And when a second vessel followed not long after, the story of meteors and myths stretched once more into something new. No longer omens, no longer mere rocks. These were interstellar messengers, ancient travelers from other suns, written into our night sky like new verses in a timeless poem. Each generation rewrites the heavens in its own language. The ancients wrote in fear and fire. The scientists wrote in formulas and charts. Today we write in pixels and gravity simulations, yet beneath all of it, the same pulse remains, a fragile desire to understand. Whether carved on stone tablets or stored in spectrographs, the yearning is the same, to know what moves above us and what it means. Imagine a single human figure standing on a quiet hill tonight, eyes lifted toward the sky. Above, a meteor glides in silence, glowing soft gold for only a moment before fading into the cradle of darkness. That moment, brief as breath, connects us to every watcher who ever lived. Those who once feared omens and those who now read orbits. The vocabulary changed, but the emotion did not. Our instruments now detect more than the naked eye ever could. They see through dust, pierce the faint glow of nebulae, and trace invisible trails of energy. We can model the flight of an ancient traveler with perfect precision, predict when and where it will pass, and even capture its reflection across the spectrum of light. But for all our graphs and simulations, the sense of timeless awe refuses to fade. It lingers quietly, like the echo of a campfire story still told under modern stars. Perhaps that's the heart of it. Each new discovery is both a step forward and a return. The same awe that made a shepherd drop his torch to stare at a falling star still hums in the circuits of our telescopes. The universe has always spoken in patterns, and we are still learning its language. From meteors to interstellar visitors, from omens to orbital data, our journey isn't just scientific. It's deeply human. When the second vessel entered our solar system, scientists tracked it with calm precision, yet in the quiet corners of their minds that ancient spark flickered again. They too looked up and wondered if this arrival meant something. If somewhere, someone else was watching us the same way. Our questions remain timeless and unanswered. Are these travelers random debris or cosmic messengers? Do they drift without purpose, or do they carry the same curiosity that burns within us? The tools have changed, from campfires to computers, but the longing remains constant. And maybe one day, when our own probes drift beyond our sun's reach, someone else will see their faint light and wonder what omen has passed across their sky. In that thought lies a quiet symmetry. The watchers becoming the watched, the myths becoming science, the science becoming myth again. And as the story of the stars continues, the silence deepens, filled not with fear this time, but with a fragile, endless wonder that refuses to fade. The night sky stretches endlessly above, a calm ocean of scattered light. Every star feels like an eye, ancient, patient, quietly observing. The narrator's voice moves gently through the darkness, asking, what if the watchers aren't only here on Earth looking outward, but out there looking back? Not with fear or threat, but with curiosity as tender as our own. For centuries, humanity has turned telescopes toward the heavens, watching planets, comets, and exoplanets drift across the infinite black. We send probes past Jupiter, study radio waves from pulsars, and map galaxies millions of light years away. Yet the thought settles softly. What if the gaze is mutual? Perhaps we are not just explorers but part of someone else's data? The way we note brightness, temperature, and motion, another intelligence might quietly record our flickering lights. Imagine Earth from afar, a fragile sphere wrapped in blue haze, glowing faintly against the dark. From a distance of light years, our radio chatter would appear as delicate pulses, faint, rhythmic, almost like a heartbeat. The signal began in the early 20th century, when we first learned to speak in radio frequencies. Those early transmissions are now more than 100 light years away, expanding as a ghostly bubble around our world. Somewhere, perhaps, that expanding shell has brushed across another civilization's instruments. Maybe they paused for a moment, noticing the strange pattern of signals, wondering who could have made them. The narrator speaks softly about how our telescopes, like eyes half closed in a dream, scan for exoplanets that pass briefly before their stars. We measure dips in brightness, map orbits, and infer the presence of oceans, clouds, and air. Somewhere beyond, another species could be doing the same, watching a tiny star near the edge of a spiral arm and detecting us as a flicker of blue. To them, our planet might seem like a pale dot with chemical traces of life. Oxygen, methane, carbon dioxide, a signature whispering, "We are here." And what if they wanted to see more? Not to invade or communicate, but simply to understand. Just as we send robotic explorers to the edges of the solar system, they might have sent their own emissaries, small, cold, durable objects capable of drifting between stars for millennia. No crew, no intent, just curiosity cast into the dark. Oumuamua and the second vessel, silent and strange, might fit that shape of thought. Their trajectories are ancient, their motions unbound by our sun. If one were a natural fragment and the other a deliberate messenger, how would we ever know? Our telescopes capture light, not purpose. We read patterns, not intentions. The voice slows, nearly whispering now, maybe we are the ones under observation. Our solar system could be a point of interest in a vast catalog. Our sun tagged as stable yellow dwarf, our Earth marked as oxygen-rich, noise-producing. From their view, we might be nothing more than a small anomaly worth logging, much like we note a comet that glows too bright or a planet that spins too slow. In the quiet between stars, even observation is an act of reverence. The universe is full of watchers, planets watching their suns, galaxies circling each other, comets gliding like slow cameras through cosmic dust. Observation might be the universe's language of love, the way it remembers itself through reflection. A soft hum builds under the narration, a suggestion of distance. Our cities emit light so bright it leaks into space. To an alien eye, the pattern of those lights could reveal our continents, our seasons, even our restlessness. They might notice how the planet glows more brightly in one hemisphere, then shifts as time and commerce turn. The auroras at the poles shimmer like emerald curtains, natural and hypnotic. Storms spin white across the oceans as if painted by invisible hands. To watch Earth from afar would be to see motion as emotion, storms of energy, bursts of light, waves of rhythm. And if they listen more deeply, past the radio noise, they might sense our smaller messengers. The faint ping of Voyager 1, still whispering from beyond the heliopause, could be their first sign of deliberate engineering. That lonely spacecraft carries our golden record. Sounds of rain, of human laughter, of greetings in dozens of languages. We built it to tell someone, somewhere, that we existed. Perhaps, as it drifts further into interstellar space, another observer has already intercepted its faint pulse, decoding the symbols and wondering about the fragile beings who sent it. The narrator breathes softly. There's no reason to fear this idea. Being watched does not mean being judged. In the cosmic scale, observation is gentle, an act of patience, not control. Just as we admire the light of distant galaxies without disturbing them, any watchers, if they exist, might simply be doing the same. Quietly recording, quietly marveling. Our civilization may appear like a brief flare, bright, then dimming. But perhaps that's how all life looks from afar, a spark against eternity. Every transmission, every light, every probe we send becomes part of a larger pattern, one we can't yet see from inside our own orbit. The narration slows to a near whisper now. The question is not whether someone is watching, but what they see when they do. Do they see the chaos or the kindness? The noise or the music? The wars or the warmth that glows between? Do they recognize curiosity as the same force that drove them to look outward in the first place? Because maybe, just maybe, the watchers and the watched are not different at all. Maybe every intelligence in the universe is bound by the same quiet desire, to know, to see, to not feel alone. As the cosmic hum fades, the stars blur into a soft cradle of light. Earth turns slowly beneath the Milky Way's shimmering band, its pulse faint but steady, a living signal drifting through the infinite dark. And somewhere, far beyond the edges of our knowing, an unseen observer might be looking back, silent, ancient, patient, seeing in us what we have always seen in them, the reflection of wonder itself. It begins with silence. A wide, patient silence that stretches from the edge of the solar system to the faintest star the human eye can name. In that silence, motion never stops. Tiny comets glide through frozen shadows, dust spirals in gentle arcs, and invisible magnetic lines hum with quiet electricity. The narrator's voice drifts through the stillness, calm as a slow tide. Every orbit, every spark of starlight, every passing traveler is part of a great, moving story. Oumuamua was not the first, and it will not be the last. The second mysterious vessel simply reminded us, there are more footsteps in the cosmic sand than we ever imagined. When astronomers look back at the data, the strange acceleration, the shimmering reflections, the unusual spin, it feels less like randomness and more like rhythm. As though the universe, in its vast indifference, hums a low and endless tune. A soft glow spills from the sun's corona, brushing a whisper of light across the path these travelers once took. Each line on a chart, each plotted trajectory, becomes a thread in an invisible web connecting all who watch the sky. The telescopes, scattered across mountaintops and frozen deserts, are our eyes in that darkness. They do not blink. They're mirrors. Breathe in starlight and exhale information. Spectrographs, wavelengths, orbits, speeds, all reduced to the poetry of numbers. Yet behind every number sits a heartbeat. The astronomer in the control room, the late-night listener, the dreamer wondering what might pass by next. Together, they are companions of a sort, humans and instruments united by curiosity, watching a night that never truly sleeps. Oumuamua, the first stranger, left behind no clear answers. The second vessel, glowing faintly as it curved around the sun, offered no explanations either. Still, their silence was not empty. It was full of meaning, a message too large for language. The solar wind, that invisible current flowing outward, tugged softly at their surfaces like an unseen hand. Perhaps that gentle pull is what links us all, from the smallest atom to the largest galaxy cluster. A cosmic tide that never stops moving. As you imagine these objects drifting beyond Pluto's orbit, fading into the thin halo of interstellar space, picture them not as lost, but as continuing a journey. They pass unseen worlds, dormant comets, fragments of frozen moons. Each encounter changes them a little, polishes, warms, then cools them again. And though they are silent, their existence speaks, proof that motion connects everything. Some scientists call them debris, others relics, a few still whisper the word messenger. Whatever name fits, one truth remains: they are real. They move through the endless night without invitation, but their arrival always leaves us changed. Each time a new object crosses the boundary of our solar system, it reminds us that the universe is neither empty nor still. It breathes softly like an ocean beneath a blanket of stars. In this quiet realization, the fear fades. The idea of being alone dissolves into the deeper understanding that loneliness itself is a kind of illusion. The same forces that carry interstellar travelers across light years also shape our own planet, our oceans, our very breath. Gravity, radiation, time, they bind everything like threads in a cosmic tapestry. The narrator's voice slows further, as if whispering to a listener already half asleep. We are all part of that drift. Every heartbeat, every orbit, every thought about what might lie beyond is another form of connection. Oumuamua may be gone, the second vessel now a dim echo in the dark, but they have joined the quiet choir of movement that defines existence. Above Earth, the stars shimmer like soft embers. Below, oceans reflect their glow. Somewhere between them, humanity looks upward, not to command the sky, but to listen. The telescopes will keep watching, the data will keep arriving, and the stories will continue to unfold in gentle ripples across generations. In the cradle of silence, a thought takes shape, simple, almost weightless. Perhaps the visitors were never meant to teach us what lies beyond. Perhaps they came to remind us of what we already are, tiny travelers ourselves, spinning through an endless night, each breath another orbit around hope. The universe hums faintly, a lullaby older than memory. The solar wind sighs against the distant dust. Somewhere, another object begins its long descent toward the sun, unseen but inevitable. And as the stars watch in patient stillness, a final reflection lingers in the dark. We were never truly alone. We were only just learning how to notice the companions quietly passing by.